Welcome to Ancient Relics Keeper, where lost truths, ancient mysteries, and forbidden history collide. Let's question the past and uncover what was never meant to be found. A 1,600-year-old Roman chalice holds a secret of modern science. The Lycurgus cup changes color from jade green to blood red, a feat achieved with nanotechnology its creators could not have possibly understood. This is its story. In a quiet, climate-controlled gallery of the British Museum, it rests inside a protective case, an object of almost impossible rarity. To the casual observer, it is simply a cup, a chalice from the late Roman Empire, small enough to be held in two hands. It appears to be carved from a single piece of opaque, milky jade-green stone. The surface is intricate, covered with figures caught in a moment of high drama. It is beautiful, it is ancient, and it is undeniably a masterpiece of Roman craftsmanship. But this object, known as the Lycurgus cup, is far more than just a relic. It is a paradox, an artifact that holds a secret so advanced that it would take 16 centuries for science to even begin to comprehend it. Its story begins not with technology, but with the myth of divine fury, a story of a mortal king who dared to defy a god. The cup is first and foremost a breathtaking piece of narrative art. It doesn't just depict figures. It tells a story, a violent and cautionary tale well known to the Romans. The central character, his body contorted in agony and surprise, is King Lycurgus of Thrace. In classical mythology, Lycurgus was a proud and brutal king who rejected the worship of the god Dionysus, known to the Romans as Bacchus. Dionysus was the god of wine, revelry, ecstasy, and the untamed forces of nature. His followers, the Maenads and Satyrs, would engage in wild, ecstatic rituals in the forests. To the rigid, order-obsessed King Lycurgus, this divine chaos was an abomination. In a fit of hubris, he attacked the god's followers, driving them from his lands and even assaulting Dionysus himself. The scene carved onto the cup captures the moment of divine retribution. It is the story's climax, frozen in glass for eternity. We see Lycurgus, his face a mask of rage turning to panic, as he raises an axe to strike one of Dionysus's followers, a nymph named Ambrosia. But he is too late. To save her, Dionysus has transformed Ambrosia into a living grapevine. The vines, thick and powerful, erupt around the king, ensnaring him completely. The carving is exquisitely detailed. You can almost feel the rough texture of the bark as the vines coil around Lycurgus's legs, torso, and arms, trapping him in an inescapable wooden cage. His struggle is palpable, his body writhing against his leafy prison. He is no longer a king in command, but a man realizing the fatal error of challenging a divinity. Surrounding this central drama are other figures who complete the narrative. A satyr, a mischievous half-man, half-goat creature, dances with glee at the king's predicament. The god Pan, another figure from Dionysus's retinue, looks on, his presence reinforcing the theme of wild nature triumphing over mortal arrogance. On the other side of the cup, a calm and victorious Dionysus appears, holding his thyrsusus staff of giant fennel topped with a pine coney as he directs the punishment. The entire composition is a powerful piece of propaganda for the cult of Dionysus, a stark warning that the gods are not to be trifled with and that their power is absolute. For centuries, this was the cup's primary identity, a vessel for a myth, a moral lesson carved in green glass, likely commissioned by a wealthy Roman devotee of Bacchus to be used in ritual celebrations. It was a treasure, certainly, but its true enigma lay dormant, waiting for a simple trick of the light to reveal itself. And it is here, in the interaction with light, that the cup transcends from a mere historical artifact into a profound mystery. When viewed in reflected light, that is, when light bounces off its outer surface, as it would in a museum display, the cup maintains its serene, opaque, jade-green appearance. The color is soothing, almost stone-like, which makes the violent scene carved upon it all the more unsettling. It's a story of rage told in a color of calm, But this is only half of its identity. The true magic happens when the cup is illuminated from within. If a light source is placed inside the chalice, a startling and beautiful transformation occurs. The opaque green vanishes instantly. The entire cup begins to glow, becoming translucent, and the color shifts dramatically to a deep, fiery blood red. It's a shocking metamorphosis. The calm, stone-like object becomes a vessel of glowing embers. The scene of King Lycurgus's punishment is no longer just a carving. It is now bathed in a spectral crimson light that completely changes its emotional impact. The red hue makes the violence of the myth feel immediate and visceral. It is the color of wine, the domain of Dionysus. It is the color of blood, the price of Lycurgus's defiance. The entire artifact comes alive, its physical properties perfectly mirroring the narrative it depicts. The change from a calm, green object to a violent, red one is a theatrical reveal, a built-in special effect that enhances the story of a man being consumed by a god's wrath. This baffling phenomenon is known as dichroism, from the Greek words di for two, and chroa for color. The Lycurgus cup is the most spectacular and perfectly preserved example of dichroic glass from the ancient world. While a few other fragments of Roman dichroic glass exist, shards found in archaeological digs across the former empire, none compare to the size, complexity, and sheer artistic brilliance of the cup. Those fragments prove that this was not a one-of-a-kind fluke, but likely a highly specialized and secretive manufacturing technique. Yet, its extreme rarity suggests that it was an art form mastered by only a handful of artisans, a secret so closely guarded that the knowledge seems to have vanished with the fall of Rome. For centuries after its rediscovery, the cup's color-changing property was a complete puzzle. How could a single solid object possess two entirely different colors? Early theories were speculative at best. Some wondered if it was made from a rare, undiscovered gemstone with unique optical properties. Others whispered of alchemy, suggesting that Roman artisans had found a way to imbue glass with magical or otherworldly qualities. There was no logical explanation within the known technological capabilities of the ancient world. The Romans were masters of engineering and chemistry, capable of creating magnificent aqueducts, durable concrete, and vibrant pigments, but the ability to precisely manipulate the properties of light at such a fundamental level seemed beyond them. It was a piece of technology that shouldn't exist. The mystery deepened because the effect was so perfect. It wasn't a muddy, indistinct shift in tone. It was a clean, dramatic switch between two distinct and vibrant colors. The green was a true jade and the red was a true ruby. This precision hinted at an intentional process, a deliberate formula rather than a happy accident. The artisans who created this must have known what they were doing. Yet they left behind no manuals, no instructions, no record of their incredible achievement. The Lycurgus cup sat for over 1,500 years as a silent testament to their lost genius. It was an object that presented a fundamental paradox. It was a work of art whose very substance was a scientific marvel, and a piece of ancient history that contained a secret belonging to the future. It was a myth carved in glass, and a mystery locked within it. The story of Lycurgus was plain to see, but the story of the cup itself was an enigma waiting for the tools of a different age to finally decode its impossible, color-changing secret. For well over a millennium, the Lycurgus cup kept its secret. After the fall of the Roman Empire, the chalice vanished from the historical record, its journey through the so-called Dark Ages a complete blank. It resurfaced in the 18th century, eventually finding its way into the possession of the renowned Rothschild banking family in the 19th century. To them, and to the connoisseurs who admired it, the cup was a masterpiece of glass carving and a baffling curiosity. They could demonstrate its color-changing trick, astonishing guests by placing a candle inside to make it glow red. But the mechanism behind the magic remained entirely inexplicable. It was treated as a unique, perhaps alchemical anomaly. How could a solid object be both green and red? It defied the known laws of materials. The cup was a ghost in the machine of Roman technology, an effect without a discernible cause. When the British Museum acquired the cup in 1958, it was subjected to the first waves of modern scientific scrutiny. Researchers could confirm its basic composition: a soda-lime silica glass, typical of the Roman period. They could identify the trace elements that gave it color. But this only deepened the mystery. The analysis didn't reveal any strange, unknown mineral or exotic substance. The ingredients were, for the most part, conventional. The secret was not in what it was made of, but in how it was made. Scientists of the 1950s and 60s could speculate, proposing that perhaps some form of colloidal suspension was responsible, but they lacked the tools to see it. Their instruments could tell them the chemical recipe but not the atomic structure. The cup was like a complex book written in a language no one could read. For decades it remained in this state of limbo. Its myth was understood, its beauty was appreciated, but its physical nature was a locked box. The key to unlocking it would not be found in the archives of history or archaeology, but in the sterile high-tech laboratories of the late 20th century. The past was about to be interrogated by the future. The journey from speculation to certainty began in earnest in the late 1980s. A team of British scientists, including archaeologist Ian Freestone and glass expert David Barber, became determined to solve the 1,600-year-old puzzle once and for all. The technology had finally caught up with their curiosity. The critical tool they needed was the transmission electron microscope, or TM. Unlike a conventional optical microscope that uses light to magnify an object, a TM fires a beam of electrons through an incredibly thin slice of a specimen. As the electrons pass through, they interact with the material's atomic structure. Magnets then focus this electron beam to create an image on a detector, revealing details thousands of times smaller than anything visible with light. It allows scientists to see the very building blocks of matter. The decision to use this technique on the Lycurgus cup was not taken lightly. To prepare a sample for a TM, a piece of the object must be removed. This meant taking a tiny fragmentous sample so small it was barely visible to the naked eye. From the priceless one-of-a-kind artifact. In 1990, with great care, the procedure was done. A minuscule sliver of glass was painstakingly removed, embedded in resin, and then sliced into a section so thin it was only about 100 nanometers thick, transparent even to electrons. This fragile slice of ancient Roman glass was then placed into the vacuum chamber of the powerful microscope. For the first time, humanity was about to look into the atomic heart of the Lycurgus cup. What the scientists saw on their screens was nothing short of astonishing. It was the definitive evidence that had eluded researchers for centuries. Suspended within the clear matrix of the glass were countless tiny spherical particles. They were almost perfectly uniform in size and evenly distributed throughout the material, like stars suspended in a glassy galaxy. The researchers had found the ghost in the machine. These particles were impossibly small. Using the powerful magnification of the TM, they were able to measure them precisely. Their average diameter was about 50 nanometers. To put that scale into perspective is to grasp the sheer marvel of the Roman achievement. A nanometer is 1/1000th of a meter. A single human hair is about 80,000 nanometers wide. These particles were over 1,000 times smaller than a single grain of common table salt. 1,000,000 of them could fit comfortably on the head of a pin. The Roman artisans, working with open fires, crude tools, and no knowledge of atomic theory, had managed to create and control materials on a scale that modern science had only begun to master in the latter half of the 20th century. They were, without knowing it, practicing nanotechnology. The next step was to determine what these nanoparticles were made of. Using a technique called energy dispersive X-ray spectroscopy, which analyzes how a material interacts with an electron beam to identify its elemental composition, the scientists solved the final piece of the puzzle. The particles were not a single substance, but a metallic alloy. They were composed of silver and gold, and it wasn't a random mixture. The ratio was remarkably specific, approximately 7 parts silver to 3 parts gold. This precision was the key to the cup's color-changing secret. The discovery of these gold-silver nanoparticles provided a complete and elegant explanation for the dichroic effect. The physics at play, a phenomenon now known as surface plasmon resonance, is both complex and beautiful. It all comes down to how these specific nanoparticles interact with light waves. When light hits the cup from the outside, reflected light, the electron clouds on the surface of the metallic nanoparticles begin to vibrate. Given their specific size and the gold-silver alloy, these particles are perfectly tuned to scatter light in the blue-green part of the spectrum most efficiently, while absorbing other colors. Our eyes collect this scattered light, and so the cup appears a serene opaque jade green. But when a light source is placed inside the cup, the physics of the interaction changes completely. Now the light is passing through the glass, transmitted light. As the light waves travel through the material and strike the nanoparticles, the same electron vibrations occur. However, in this configuration, they absorb the blue-green wavelengths and scatter the light at the opposite end of the spectrum, the long wavelengths of red light. This scattered red light is what passes through the rest of the glass to reach our eyes. Consequently, the entire chalice glows with a fiery, translucent ruby color. The mystery was solved. It wasn't alchemy or a magical stone. It was a triumph of applied physics, achieved 16 centuries ahead of its time. The size of the particles was critical. If they had been much larger or smaller, the effect wouldn't work. The alloy was critical. A different ratio of gold to silver, or a different metal entirely, would have produced different colors or none at all. The even distribution was critical. A clumpy, uneven mixture would have resulted in a muddy, inconsistent color. The Roman artisans had, through either extraordinary luck or a lost tradition of masterful experimentation, achieved all three conditions perfectly. The 1990 investigation closed the book on the scientific question of how the cup changes color. But in doing so, it opened a far more profound historical paradox. How did the Romans do it? The unlocking of the scientific secret had only served to deepen the mystery of its creation. The 1990 discovery of nanoparticles inside the Lycurgus cup was a moment of scientific triumph. It definitively answered the centuries-old question of how the cup performed its color-changing magic, replacing speculation and wonder with the elegant physics of surface plasmon resonance. Yet, in solving one mystery, it created a far more profound and challenging one. The electron microscope revealed a level of material engineering that was, by all accounts, impossible for its time. This discovery presents the central paradox of the artifact. Roman artisans, working in the 4th century with rudimentary furnaces and no concept of atomic theory, achieved a feat of nanotechnology that modern science only began to grasp in the 20th century. How did they do it? This question forces us to peer across the vast gulf of time and into the smoky, firelit workshops of the late Roman Empire. It pushes us beyond the comfortable confines of established history and into a debate that pits scientific probability against the limits of human ingenuity. There are two primary schools of thought that attempt to resolve this paradox, each compelling in its own way. The first is the theory of accidental genius, the idea that the Lycurgus cup is the product of a breathtakingly lucky mistake. The second, more tantalizing theory, is that of a lost art, a deliberate and secret craft, perfected through generations of empirical trial and error, and then lost to the chaos of history. The theory of the brilliant accident is, for many scientists, the most plausible and rational explanation. It adheres to what we know about the technological landscape of ancient Rome, and doesn't require us to assume the existence of a secret, advanced science. In this scenario, the creation of the dichroic glass was entirely unintentional. The process would have started with a batch of molten glass in a crucible. The crucial contamination, the addition of gold and silver, could have happened in several ways. One likely source is contamination from the workshop itself. Roman artisans were excellent recyclers, frequently melting down old, broken glass, known as cullet, to create new objects. It is conceivable that a piece of gilded or silver-inlaid glass was accidentally mixed into a batch of clear cullet. Alternatively, the contamination could have been environmental. Many Roman workshops that produce luxury glass may have also been involved in fine metalworking. The air in such a place would have been filled with microscopic dust from the grinding and polishing of gold and silver. This metallic dust could have settled into the crucible of molten glass, invisibly seeding it with the necessary nanoparticles. A stray tool, previously used for metalwork and not properly cleaned, could have introduced the precious metals. In this view, the artisan had no idea that this specific batch of glass was special until it was finished and cooled. However, simply adding gold and silver dust is not enough. The true magic lies in the size and distribution of the resulting nanoparticles, which is determined by the precise temperature and duration of the heating and cooling process. The accidental genius theory posits that the glassmaker, by sheer chance, followed an exact thermal recipe. They may have heated the crucible to a specific temperature, held it there for just the right amount of time for the metals to dissolve and then precipitate into nano-sized spheres, and then cooled it at a particular rate. This process, a sequence of hundreds of variables, would have had to align perfectly by happenstance. The artisan, upon pulling the finished cup from the annealing oven, would have been as surprised as anyone by its strange optical properties. The rarity of the cup, in this light, is its greatest supporting evidence. If it were a 1 in a billion fluke, it explains why we have not found dozens of other examples. It was a masterpiece born from a confluence of improbable events, a lightning strike of craft. And yet, for all its scientific elegance, the accident theory is challenged by the sheer perfection of the artifact. Accidents in craftsmanship are typically messy. They result in impurities, inconsistencies, and flawed outcomes. The Lycurgus cup is the opposite of flawed. The nanoparticles are remarkably uniform in size, around 50 nanometers, and are evenly distributed throughout the glass matrix. This uniformity is what produces the clean, dramatic shift from a pure jade green to a vibrant ruby red. A random contamination would more likely result in a muddy, uneven color, or a vessel with dichroic streaks in some parts and not in others. Furthermore, the existence of other, albeit fragmented, pieces of Roman dichroic glass suggests this was not a singular event. It may have been an exceptionally rare technique, but it was a technique nonetheless. The perfection of the cup whispers not of accident, but of control. This leads us to the second, more compelling theory, that of a lost art. This hypothesis suggests that the Lycurgus cup is not an accident but the pinnacle of a highly secretive and specialized craft, developed through painstaking empirical observation and passed down through a small elite guild of artisans. These craftsmen would not have understood the physics of surface plasmon resonance, but they didn't need to. They only needed to know that it worked. This is the essence of empirical science, knowledge gained through observation and experimentation, not theoretical understanding. In this scenario, we can imagine a lineage of master glassmakers. Perhaps a generation before, an artisan noticed that a batch of glass contaminated with trace amounts of gold and silver dust produced a strange, faintly colored effect. Intrigued, he or his apprentices would have begun to experiment. They would learn through endless trial and error, like ancient alchemists, that a specific mixture of finely ground gold and silver, perhaps from old coins or jewelry, was required. They would have developed a recipe, a set of instructions passed down orally from master to apprentice. This recipe would have been a closely guarded trade secret, the source of the workshop's fame and wealth. The instructions might have sounded like this. Take a scoop of sand from the Belus River. Add 3 parts soda ash. For the color, take 1 silver denarius and a sliver of gold, and grind them with the porphyry pestle for the duration of a sundial's shadow. Add a pinch of this dust to the crucible when the fire roars hottest. Heat it until the flame above the glass turns a faint purple. Then let the furnace cool for 2 days without opening the door. They wouldn't know they were creating 50-nanometer particles. They would only know that this specific ritualized process yielded the miraculous color-changing glass. Their knowledge was practical, not theoretical. They had mastered the how, not the why. This theory better explains the cup's perfection. The uniform particle size and distribution are no longer a miracle of chance, but a testament to a refined, repeatable technique. It also explains the existence of other dichroic fragments as either earlier experiments, less successful attempts, or products from the same secretive workshop. The extreme rarity would be due to the immense cost of the materials. Gold and silver were not used lightly and the difficulty of the process. This would have been a luxury item commissioned only by the wealthiest echelons of Roman society, emperors, senators, or devout followers of a mystery cult with deep pockets. If this was a deliberate art form, why did it vanish so completely? The answer likely lies in the turbulent history of the late Roman Empire. The 4th century, when the cup was made, was a time of immense social, political, and economic upheaval. The empire was beginning to fracture. Constant civil wars, barbarian invasions, and economic collapse led to the breakdown of the intricate trade networks that supplied workshops with exotic materials and the wealthy patrons who commissioned their work. Luxury craft guilds were among the first casualties of societal collapse. Knowledge in the ancient world was fragile. It was often held in the minds and hands of a few masters, not written down in comprehensive manuals. If the single workshop that had perfected the dichroic glass technique was destroyed in a raid, if its masters were killed in a war or died from a plague, or if the economic downturn simply made their craft unsustainable, the secret could die with them. Within a single generation, 1,000 years of cumulative empirical knowledge could be lost forever. The Lycurgus cup, then, may be the last surviving masterpiece of a forgotten art, a final brilliant flare from a candle that was about to be extinguished by the winds of history. Ultimately, the absolute truth of its creation remains locked in the past. It could be a sublime accident, or it could be the silent legacy of a lost lineage of geniuses. What is certain is that the Lycurgus cup fundamentally challenges our modern perceptions of the ancient world. It is a tangible reminder that technology is not a linear progression. It demonstrates a profound gap that can exist between practical capability and theoretical understanding. The Roman artisans who forged this object stood on a peak of empirical achievement, able to manipulate matter on a scale that would remain invisible to the human eye for another 16 centuries. Whether by a stroke of luck or by secret wisdom, they created a paradox in glass that continues to bridge the worlds of science, myth, and mystery. Modern researchers are still experimenting with the cup's unique properties, finding they could have applications in medical diagnostics. The full potential of this 1,600-year-old technology is only now being understood, a remarkable secret hidden in plain sight. Thanks for exploring with Ancient Relics Keeper. Stay curious, question everything, and remember the truth is often buried deeper than we think.